Let's have a look at a couple of exam 1 methods questions here. So random variable x is normally distributed with a mean of 24 and a standard deviation of 3. Now recall that that's going to be sigma squared, so the standard deviation squared, so that's going to be 9. Right, the random variable z is the standard normal distribution, which means it has a mean of 0, standard deviation of 1, which means it's a variance of 1. So what do they tell us? They tell us that the probability on the z distribution that it's greater than 1 is equal to 0.16. This will be important, okay, and this will be relevant to this part of the question. So what I'm going to do is quickly draw the z distribution. There's 0, 1, 2, 3, -1, -2, and -3. Okay, so z greater than 1, that means the area under the curve here is going to be 0.16. All right, now let's have a look at this particular distribution. X is normally distributed with a mean of 24, 27, 30, 33, 21, 18, 15. Okay, so we want to know the chance of the random variable being greater than 21. So that would be the probability of this part here. Now notice that the symmetry here, that part there, the tail listed there, or the right tail there, is the same as a left tail here. Okay, so if I want to work this one out here, all I'll do is just say it's 1 take away whatever this is on the z distribution, which is 0.16, okay, because it'll be the same as this part here. So this probability x greater than 21 is actually equal to the probability that z is greater than, x less than 21 is greater than z greater than 1. These two probabilities will be exactly the same, or the areas will be exactly the same. Right, so it's 1 take away 0.16, which is 0.84. Right, now we want to get the probability that it's between 24 and 27. So there's 24, there's 27. Okay, so I know that half of this, so from 24 to 33, or 24 to positive infinity, will be 0.5. Okay, and all I want to do then is remove, I'll try to draw this in a different color. Let's see what I got here. I want to remove this part here to get 24 to 27. So I only want this part here. Now I already know that this part from the first standard deviation to the right and onwards has an area of 0.16. So this time around I can simply go, it's 0.5, not all of it, it's half of it. Take away this part in violet here, and what that's going to mean, 50 take away 16, 40, 34, 0.34. Okay, so that part there has to be 0.34. Right, the standard conditional at the end. Okay, so what are the chances of it being less than 21 given that it's less than 24? So we know that it's less than 24, so we know that only the probability is only going to be 0.5. So we just need to do a little bit of method mark here. So we're going to say that this is probability is, so that is equal to the probability that the random variable is less than 21 over the probability that the random variable is less than 24. Okay, this part here, we know that less than 24 is 0.5, all right, and less than 21 by symmetry is the same as greater than 27 or greater than 1 over here, so we're just going to put that over 0.16, 16 over 50, 8 over 25. All right, so whenever they take it to the z, they're basically giving you some information about the z curve. You've just got to apply that to the particular curve or the transformed z curve, apply that area there into these amounts here. Right, let's go to question 9. Right, so we want to find the stationary points of the graph of f, where f is that function there. So the first thing we'll do is f dash x, we'll get the derivative function 3x squared take away 2ax, and we'll let the derivative equal 0. So we'll basically say, hey, when's your gradient 0? Can you tell me? 0 equals x, 3x take 2a, x is equal to 0, x is equal to 2a on 3. All right, that looks appropriate. So that is obviously going to turn there at 0, 0, and this one here will be at 2a on 3 comma, and all we'll do is to work out y, we'll do f of 2a on 3 equals um, 8a cubed over 27, take away 4a squared, a cubed over 9 times 3, that's 12, negative 4a cubed over 27. Okay, so let's list them as coordinates or ordered pairs. 2a on 3, negative 4a cubed on 27. Right, a is positive. That means they're saying it's a negative number, which seems appropriate there. Yep, all good. Okay, find the values of n where n is a real number for which f of x equals n has two solutions. Right, so basically f of x equals n. What we've got is a straight line. So what we're doing basically is we're drawing straight lines where it's equal to n. So we're drawing straight lines along here, and what we want is two solutions or two intersection points. So where they're going to occur is, I'm going to draw the first one. What it's going to do is nick the stationary point and keep going through this second point here. So we've got 1 and 2 intersections. The second one is along the line here. First intersection, second intersection. Everywhere else you can see that there's one intersection or 3 intersections through this part here. So it's actually going to be at the stationary points where this is going to occur. So find the values of n. So n is going to equal the y values of the stationary points. So n is when n is equal to 0. Okay, so when n is equal to 0, or when f of x is equal to 0, we get 1, 2 solutions. And when f of x is equal to this value here, negative 4a cubed on 27, that stationary point there, or the y value of that stationary point there, we're going to get 1, 2 solutions. Okay, so it's going to be n equals negative 4a cubed on 27. Okay, the point u f of u lies on the graph of f. Tangent is drawn to the graph of f at the point u. No other tangent to the graph of f has the same gradient as this tangent, so it's unique. All right, so let's check it out. So anywhere along this part here, including the stationary point, is going to produce the same gradient as somewhere along this line here. So it's got to be in this section here. Now what happens is we get like small negative gradient along here, and the gradient changes, it increases to a point here, and then it decreases back again. So these are repetitions of here. So that point there is going to be the unique gradient. Okay, so what we're looking for is we're going to get the double derivative of f of x. Okay, so we want to get a situation where we want the maximum rate of change. Okay, we want the highest rate of change. So, and what we want basically is, so this is the original graph here. Remember that the gradient graph is going to look as follows. So this is a 0 gradient point. Okay, so we're going to have 0 gradient here. We've got a positive gradient, a negative gradient, and then a positive gradient. So we're looking for when f dash x, because that's what that line is there, f dash x is equal to 0. When does it have a stationary point? And that will give us the unique tangent for the graph. So the way we're going to do this basically is find f double dash x, which equals so it's going to be 6x take away 2a. So we're looking for when the gradient function when the graph of the gradient function has a stationary point. So we're going to let f double dash x equal 0. A equals a on 3. All right, the points v and w also lie on the graph. The tangents to the graph of f at the points v and w have the same gradient. Find v plus w. All right, I'm not sure how to find v plus w, but all of these go pretty much the same way. So what we do is we find f of v, and we f dash v, we find the gradient at point v, we find the gradient at point w, and we equate them. Okay, so what we do is we pair them off, and let's just see what happens. All right, so our gradient is that, so it's going to be 3n squared take away 2an. Let's just check that. 3n squared take away 2an, yeah, looks good. It's not n, it's f of v. What am I doing? Okay, 3v squared take away 2av, and this one is going to be 3w squared take away 2aw. All right, so looking at what we're trying to do, we're trying to find out v plus w. So that means that in this, instead of making like either v or w the subject, we need to make v plus w the subject. So it'll take a little bit of manipulation, but I'm going to write this as 3v squared take away 3w squared equals 2av take away 2aw. Right, then what I'm going to do is yank 3 out as a common factor, which is v squared take away w squared, 2a v take w. All right, and what you can see or maybe see unfolding is that the v take w is going to be crossed out, and the way we're going to do that is we're going to rewrite this as difference of perfect squares, v plus w, 2a v take w. That cancels out with that because, so I can divide by v take w because v is not equal to w, which means that can't equal 0. So we're left with v plus w equals 2a on 3. There we go. That's a tough one. Often with these last ones, you don't really know where they're going. You just sort of do something and try it out and see what it actually starts to say to you. So you've just got to let the algebra kind of unfold before you. So when you don't know what to do with the last question, you just try something, you just bang in some values, see what you get, and invariably comes out like something like this.